What is a discrete function? Well, before we talk about discrete functions, we should understand that most of the functions we've been talking about so far have been continuous functions. Now, if you want to know the difference between a continuous function and a discrete function, we can take a look at their graphs or an example of each type of function, and it's pretty easy to see the difference. A continuous function might look something like this, right? It's just a line that goes on, forever. That's a continuous function. A discrete function is something that looks like this. It's a set of points which are not connected, right? It's not continuous, it's discrete. And so why do we have sometimes discrete functions versus continuous functions? Well, continuous functions are very useful to represent things like temperatures, heights, proportions, position, volume, speeds, anything really that changes over time or in relation to an independent variable, right, your x and y. In other words, continuous functions are very good for displaying things which are measured. Whereas discrete functions are good for examples where you only have specific y values. So for example, if you're rolling dice and you want to show how many of each number on the side of a dice you've rolled. If you're picking a card from a deck and you want to show how often each card is picked. Or let's say, the number of something that you own, like the number of shoes or something like that. In other words, a discrete function is useful to display things that are counted. Right? So you wouldn't use a discrete function to show the way temperature changes over time because temperature is changing continuously. And you wouldn't use a continuous function to show how many times you rolled every side of a die if you're just rolling dice, right? For that you would use discrete, right? A discrete function because you just have one particular y value for every x value, right? So whether something is measured or counted is going to dictate whether we have a continuous or a discrete function. Now let's look at an example of a discrete function. Let's say you have f of x is equal to 3x minus 1. Well, right now we don't know if this is continuous or discrete. In order to know which one it is, we have to define the domain. And so if the domain for this function is given to us as -2, -1, 0, 1, and that's it, then we only have these four x values. So when you go to make your table of values, x and y, and you plug in the x values, -2, -1, 0, 1, you get -2 times 3 is -6 minus 1 is -7. For -1 you get -4, -1, 2. So these are the only points that you have on your function, right? Meaning that the function is discrete, right? It's not continuous. So you have -2, -7, you have -1, -4, you have 0, -1, so 1 right there. You have 1, 2. So you have these dots on your function, but you don't connect the dots, right? Because it's not continuous. You only have these points. So this would be an example of a discrete function. So again, discrete functions, they simply represent situations with a set number of x values, right? With a domain that is defined as specific x values. So it's not continuous.